Hello students, welcome back to my channel. Today we will study the topics of ring theory, that is abstract algebra, ring homomorphisms. Now let's get started to a theorem. If phi from R to R dash be a ring homomorphism, then first phi of 0 is equal to 0 dash, where 0 is identity of R and 0 dash is identity of R dash. Second, phi of minus A is equal to minus of phi of A. Now, we know that 0 plus 0 is equal to 0. So, इस पे हम अगर phi ऑपरेशन यूज करें, phi 0 plus 0 is equal to phi of 0. अब ये homomorphism था, so it preserves the operation phi of 0 plus phi of 0 is equal to phi of 0 प्लस 0 डैश. क्यों हम यूज कर सकते हैं कि phi of 0 एलिमेंट है r डैश का एंड r डैश में हमारे पास आइडेंटिटी है, एडिटिव आइडेंटिटी 0 डैश. सो phi of 0 बोथ साइड से कैंसिल आउट हो जाएगा. phi of 0 इज इक्वल टू 0 डैश. सेकेंड प्रॉपर्टी को प्रूव करने के लिए a प्लस ऑफ माइनस a इज इक्वल टू 0, which in turn implies phi of a plus of minus a is equal to phi of 0, which in turn implies phi of a plus phi of minus a is equal to 0, because phi of 0 is 0. More precisely, I should say phi of 0 is 0 dash, which in turn implies phi of minus a is equal to minus of phi of a. Now, कर्नल की डेफिनेशन देखते हैं हम. ये भी होमोमॉर्फिज्म से रिलेटेड होता है. Kernel, if phi from R to R dash is a ring homomorphism, then kernel of phi is equal to x belonging to capital R, such that phi of x is equal to identity of the other ring, codomain basically, 0 dash. Now kernel of phi is an ideal of R. It can be easily shown. आइडियल की जो प्रॉपर्टीज होती हैं, एक तो इसमें से कोई भी दो एलिमेंट्स लो, x एंड y, देन x माइनस y शो कर दो दैट इट बिलोंग्स टू कर्नल ऑफ phi. एंड सेकेंड, इफ r बिलोंग्स टू कैपिटल R, then rx belongs to kernel of phi, where x belongs to kernel of phi and x comma xr belongs to kernel of phi. Then we can say that it is an ideal of R. Now third property, kernel of phi is equal to 0 if and only if phi is 1 1. इसका प्रूफ भी इजी है काफी. अब एक प्रॉब्लम करते हैं. That is, if R is a ring and phi from R to R dash is a homomorphism, where condition है R dash is an integral domain such that kernel of phi is not equal to R, then we can show that f of 1 is unity of R dash, where R is a ring with unity. So अब इसका प्रूफ देखते हैं. Let A dash belong to R dash be any element of R dash, then we have to show that f of 1 A dash is equal to A dash f of 1 equal to A dash, right? So इसको शो करने के लिए हम कैसे करेंगे? f of 1 A dash minus f of 1 a dash is equal to 0 dash. ये मैंने ये दोनों यहाँ पे सेम ही चीजें ली हैं. f of 1 into 1 a dash minus f of 1 a dash is equal to 0 dash, which in turn implies, since it is a ring homomorphism, so f1 a dash, I take f1 common, minus a dash equal to 0 dash, which in turn implies, since it has r dash is an integral domain, if either f of 1 is equal to 0 or f of 1 0 dash, a dash minus a dash is equal to 0 dash, which in turn implies either f of 1 is equal to 0 dash or f of 1 a dash is equal to a dash. अब अगर f of 1 is equal to 0 dash है तो इसका क्या मतलब है, 1 belongs to kernel of f. Now अगर 1 belongs to kernel of f हो जाएगा and we know kernel of f is an ideal of R, so अगर किसी भी R के अंदर उसकी यूनिटी आ जाए, so it would, उसका क्या मतलब होता है कि उस ideal, that ideal is equal to the ring itself. अब हमने प्रॉब्लम में ये स्टेटमेंट दे रखी है कि कर्नल एंड एफ शुड बी नॉट इक्वल टू आर, सो दिस केस तो पॉसिबल नहीं होगा. हेंस दिस केस इज ट्रू विच वी नीड टू शो बेसिकली. सिमिलरली वी कैन शो दैट a dash f of 1 is equal to a dash. Question 2. If f from R to R dash be an onto ring homomorphism where R is a ring with unity, then we have to show that f of 1 is unity of R dash. Similar lines पे show करेंगे, a dash belongs to R dash be any element of R dash. अब अगर f onto दे रखा है हमें तो there exists a belonging to R such that f of a is equal to a dash. Now a dash f of 1 is equal to f of a f of 1. अब f हमारा होमोमॉर्फिज्म था तो 1 अंदर आ जाएगा हमारा, which in turn implies f of a, that is a dash. Similarly, we can show f of 1 into a dash is equal to a dash, which in turn implies f of 1 is the unity of r dash. Now question 3. We have an isomorphism f from R to R dash such that f of 1 is not a unity of R dash where 1 is the unity of R. ये कोई हमें एग्जाम्पल शो करना है बेसिकली. इससे हमें ये तो पता लग गया कि हमें f onto नहीं होना चाहिए कि तभी पॉसिबल है ना ये. एंड दूसरा या तो ये होना चाहिए R dash should be not an integral domain and kernel of f can be equal to R. उस केस में ये सब पॉसिबल है. तो एक मैप हम लेते हैं एज एन एग्जाम्पल, f from z to z such that f of x is equal to 0 for all x belonging to z. That is 0 isomorphism or homomorphism. So f तो homomorphism है, it can be easily verified, and f of 1 यहाँ पे 0 आ रहा है, which is not a unity of z, क्योंकि unity of z तो हमारा 1 होता है इसलिए. Now remarks देखते हैं. If we take a map f from z to set of even integers defined by f of x is equal to 0 for all x, then इस केस में 2z के पास तो कोई यूनिटी होती ही नहीं, does not have unity, while z has 1 as unity. सिमिलरली अगर हमने कोई इसी फंक्शन में हमने कोई और मैप डिफाइन किया इस हिसाब से, f of x is equal to 2x is a group isomorphism, so z is isomorphic to 2z as group, but it is not ring isomorphism. क्यों? क्योंकि Z has a unity while E does not possess unity. So it is not a ring isomorphism. In fact, in this case, F is not even a ring homomorphism.